MET 3531 Differential Equations 2 Lesson 4 Laplace Transformation Part 2 of the video. So if that you have to know these Laplace transformations. So for the basic functions ft equals 1 over s, so we proved those most of the things, and t 1 over s square, t square, factorial 2 over s cube, and if it is t to the power n, that is factorial n over s to the power n plus 1, and if sin a t is there, a over s square plus a square, then cos a t, that is s over s square plus a square. Above formulas are valid for s greater than 0. And also there are some special functions. E to the power a t is equals 1 over s minus a, and also shin a t is equals a over s square minus a square, and cos a t is equals s over s square minus a square. The above three formulas are valid for s minus s greater than a. So, and also you have to remember how to prove these. I think it means how to take on these answers using the definition, right? If these you can see in a problem without using the definition, you can write this at once. And inverse Laplace transformation definition. The inverse Laplace transformation f of s is function of f of t such that L f of t is equal fs f of s. If we denote the operation of taking Laplace transform by L and taking the inverse Laplace transform by L inverse, then L f of t, that is equals to f of s, equals L inverse f of s. If we take L inverse f of s, that is f of t. And conversely, L inverse f of s equals ft, and if we take the Laplace transform of L f of t, that again create f of s, right? This is used for both sides. And the theorem L f of t plus or minus gt. So if you know that, if we already know if that two functions given separately, two functions are given, so we can write those, we can take the Laplace transform of these functions separately. And if you take inverse, you can write that is also separately. That is the first rule of that theorem. And if any real number a, L aft, we can take that, we used all those things here. If it is a real number, so you can take out from the Laplace transforms whenever both sides exist. So if we take L inverse, that is also we can write in this way. Okay, so and these are some examples. So using the definition of the inverse Laplace transform, obtain the following. So then if you see in this, you know that, so that is just like integration. Okay, so you know that there is a rule, L t to the power n equals, what is it, n over s n plus 1, but it is not given in here, but we can create that, no? So therefore I am writing, we can write this how, L inverse, right? Then to create this here 5, it means here it need to be factorial 4, no? Then s to the power 4 plus 1 can be created here, but we have to divide this by this value, no? Then we can take out from this bracket 1 factorial 4 L inverse factorial 4 over s 4 plus 1. So what is this then? Instead of this we can write LTN, right? L inverse LTN, Tn means t to the power 4 is here, right? Then 1 over factorial 4 multiplied. Inverse and L is cancelled, then 1 over factorial 4. Factorial 4 means 4 multiplied by 3 multiplied by 2 multiplied by 1 equals here t to the power 4. Then the answer, final answer we can take here 24. T4 t to the power 4 over 24. Right? This is the answer. The next one, the another example. L inverse s square over 64 plus 64. So if we look at this format, we can remember what is sin 80. No, what is sin 80? That is a over a square plus a square. No, so we can create sin 80s here. For that, how we can write here 8 square? No, a over 8 square, it means we need to put 8 plus a square plus 8 square L inverse, then divide by 8. No, 1 over 8 times, then 1 over 8. So this part is what? Sin 80. It means sin, in here a is 8, sin 80. This is the answer, right? Then this one, L inverse 3s minus 2 s cube s r. In that case, in these kind of cases, right, so you have to use the partial fractions. So then here first we find the partial fraction, 3s minus or 2 s cube plus s square plus 4, no, equals there we can write here a square plus bs plus c over s cube plus ds over e, ds plus e over s cube plus 4, right? So this, then you can take the common denominator and equal for these coefficients. Then you can find a as 1 over 8. Try this in yourself. B as 3 over 4, C as minus half, D minus 1 over 8, and E minus 3 over 4. Then I can write s over 2 equals s cube s square plus 4 equals a equals 1 over 8 s square, b equals 3 over 4 s minus half, c equal half, then is s cube plus d equals minus 1 over 8 s minus 3 over 4 over s square plus 4, right? Then I can multiply this whole equation by 8. Then what is coming there? Oh, I can take separately, no? Then x square over 8s cube plus 3s over 4s cube minus 1 over 2s cube plus, sorry, minus s over 8 times s plus 4 minus 3 over 4 times s square plus 4. Right, now I can apply here L inverse. Instead of this part we can write, then you can simplify, no, this 1 over 8 is 1 over 8s plus 3 over 4s square, here also you can cut, minus 1 over 2s cube minus s over 8 s square plus 4 minus 3 over 4 s square plus 4. Now you can write separately 1 over 8s plus 3 1 wait 1 over s, no, we can take out from the bracket 8, 1 over 8 times L inverse 1 over s plus 3 over 4 times L inverse 1 over s square, right, half times L inverse 1 over s cube minus 1 over 8 times L inverse s over s square plus 4, no, right, minus 3 over 4 times L inverse 1 over s square plus 4, right, we can apply separately. 1 over 8, 1 over s means, you know that is 1, L1 is created as 1 over s plus 3 over 4, 1 over s square means 1 over s square means t, no, so these things here according to this, right, according to this I am right, okay, 1 over s square means t minus half times 1 over s square we can write t square, 1 over s cube we can write t square, no, minus one over 8 L inverse, this is I can write s over s square plus 2 square, no, then what is this, cos at, like, then this one I can write 3 over 4 here 2 square, it means I need 2 is there, that means I have to multiply it by half, then L inverse, then I half multiply, then multiplied by 2 s square plus 2 square, then this is, now this is cos 2t and this is sin 2t, I create that, then I can write here 1 over 8 plus 3t over 4 minus t square over 2, here minus cos 2t, no, cos 2t over 8 minus 3 sin 2t, here 8, this is the answer, that is the Laplace transform of this one, okay. So if it is come like this form, you have to take the partial fractions and then apply the inverse Laplace transformation separately, right, then you can take this final solution. And there is another theorem, if a is any real number, then L e to the power at f of t is equals fs minus a, where f of s equals lft, that is L to the L Laplace transformation of eat times ft, lft times s goes to s minus a, this is known as the first translation theorem of the shifting property. So this is the formula we can take through this theorem. I will explain this through an example, then you can easily understand rather than this equation, okay. So this is one equation, L to the before that I am writing here the L EAT times FT, L EAT time f of t, no, f of t equals LF of t, L f of t, where s goes to s minus a, right. then here also in that same format, right? Therefore we can write f of t. Here f of t is equals t cube. So then we can write this how? Lf of t only, right? It means L t cube only, right? According to this formula. But now s is goes to s minus a. Now here a, then here a equals 5. S is goes to s minus 5 then. I think you got the idea. So we can f of t we can write, if it is in that form EAT over f of t, then you can write f of t only. But s goes to s minus a. In here a is 5, then s goes to s minus 5. Then you can do the simplification. So if t to the power 3 is given, you can write factorial 3 over t to the power 4. But s goes to s minus 5, no? Then sorry, no, here not t to the power 5, here s to the power 4, s to the power 4, s to the power 4, then s goes to s minus 5. So 3 cube instead of s, now s is goes to s minus 5, no? S minus 5 to the power 4, right? That is a way of using that theorem. There is another example that is also same, e to the power 80 times f of t. Now f of t is equals 40. Then I can write how? L to the power f of t means cos 40. That is only cos 40. But s goes to s minus a. Now a is equals minus 2. S minus minus 2, that means s plus 2, right? Then you know that cos 40, cos 8, if cos 80 is there, you can write s over s square plus a square. This is the formula now. Cos 80 equals s over s square plus a square, right? Similarly here we can write, here a is equals 4. Here a is equals 4. Then I can write s over s square plus 4 square, where s is goes to s plus 2, right? S is equals to s plus 2. Now instead of s I have to substitute s plus 2. Square 4 square is equal to 16. That's all. That is all about the Laplace transform. However, I am going to explain another few examples for your convenience. So I am taking another example, example 1. Compute the Laplace transformation, the Laplace transform of the function e to the power 4t plus 5. This function is continuous function, that is continuous function, right? So according to the definition, right, according to the definition, L f of t equals 0 to infinity e to the power minus st f of t over dt. This is continuous, 0 to infinity, that is continuous, right? Here also continuous, no harm, right? That is same as the examples we discussed earlier. Therefore I am just writing L f of t is equals e to the power 4t plus 5. No, I can write separately then. L e to the power 4t plus 5 is constant, no? Then L to the power, sorry, L transform 1, no? That is constant, no? Then 4t, if EAT is there, I can write how, what is the 1 s minus a, no? Using this I can write E40 1 over s minus 4, no? 1 over s minus 4, 5 multiplied by L1 means 1 over s, no? 1 over s. Then finally I can write the answer as s minus 4 plus 5 over s. This is the answer. That is not, there's a Laplace transform only, right? And another one, that is continuous function. If now I am going to consider the discontinuous function. Second example, I am going to find the Laplace transform of that discontinuous function. Discontinuous function, this function is given f of t equals 0, where 0 to 6, then 3 where t right function I am writing f of t equals 0 where t goes 0 to 6, that is 3 if t greater than or equals 6. So you know that according to the definition, LF of t equals 0 to infinity e to the power minus st f of t times dt. But there are two values, so we have to modify this equation like this way. Now LF of t equals 0 to 6, one function, no, 0 to 6, but f of t equals 0, no, e minus st instead of f of t 0 times dt, plus then again goes 6 to, sorry, here 0 to 5, no 0 to 6, right, 6 to infinity, 6 to infinity it goes, that is e to the power minus st. Now f of t equals 6, no, so 3 dt. So this part goes to 0, then this part becomes 0, plus 3 6 to infinity e to the power minus st times dt. So I can integrate this e to the power minus st over minus s, which goes to 0 to 6. Then if 3 to the power 3 over minus s, if you substitute infinity, 1 over infinity, that is 0, then here e to the power minus s times 6, here minus minus plus, no, then 3 e to the power 6s over s. This is the answer. If that is discontinuous, so you have to consider this equation according to the intervals. If there are 3 intervals, you have to write this 3 times. It means 0 to 2 one value, 2 to 5 another value, then 5 to infinity another value. So then you have to do integration 3 times. That is only difference there, that the function is discontinuous, right? So then now we considered only then how we are finding the Laplace transformation and the other one inverse Laplace transformation. But in that our sense, then our purpose is to apply these for the differential equations, to solve differential equations easily. So for that purpose I use another example to explain how we can apply this in our differential equation. So a differential equation is given as dy by dx minus 3y equals e to the power 2x, where initial condition y 0 is equals to 1, right? So you have to keep in mind this equation to convert this, that is L f dash t, we discussed this earlier, that is s f of s minus f naught, no, already you know that f of s means L f of t, no, f of t s times L f of t minus f naught. So we can use this equation. Then now I am going to apply the Laplace transformation. Then let L yx equals ys, right? Ys. Now I am going to apply the Laplace transformation. So dy by dx means f dash t. So that means we can write this way. How? Instead of f dash t, s f of s minus f0. No, that is f dash t. Then I am applying like this way. Minus 3 y, that is y, no, 3yx equals Laplace transformation. Here that I applied Laplace, I wrote at once, right? It means Laplace transformation of y dash x. Then I wrote this part. They both I did at once. That's why I wrote this equation directly. Then here Laplace transformation of e to the power 2x. Laplace transformation of e to the power 2x. Right? So then here f of s equals L f t, no? Then I can write s L f of t means yx minus 3L y of x equals Laplace transformation of this e to the power at equals 1 minus 1 over s minus a, no? 1 over s minus a. 1 over s minus a. We can apply here 1 over s minus 2, ne? Here a is equals 2. Then here y of x is common, right? Laplace transformation of y of x is common. Then s minus 3 is creating here. S minus 3 is creating here. No. Then 1 over s minus 2. Then Laplace transformation of y of x is come as 1 over s minus 2 times s minus 3, right? 1 over s minus 2 times s minus 3. Now if it is come like this way, we have to find the partial fractions, right? If you find the partial fractions, I can write s minus 1 over 1 over s minus 2 times s minus 3. I can write a over s minus 2 plus b over s minus 3. Then you can solve this. You can find a equals minus 1 and b equals plus 2. Then this equation you can write s minus 2 times s minus 3 equals minus 1 over s minus 2 plus 2 over s minus 3. Now therefore here that is y of L y of x equals this one, 1 over s minus 2 plus 2 over s minus 3. So then we can find yt, no? Yt means we have to find inverse Laplace transformation of 1 over s minus 2 plus 2 over s minus 3. We can take separately inverse 1 minus 1 over s minus 2 plus 2 times L inverse 1 over s minus 3. So you know that e to the power at again I need that one, e to the power at equals 1 over s minus a. Now by using this we can write here minus e to the power at s minus 2 1 over s minus 2 e to the power 2x. No, by using this, right, I can write plus 2 times e to the power minus 3x. Again I use this equation. Then finally I can write yt equals 2 times e to the power 3x minus e to the power 2x. This is the final answer, right? This is a way of using the Laplace transformation in a differential equations, right? I am going to discuss one more example with you. Finally, fourth example, solve the initial value problem y double dash plus y equals 2 where y naught equals 0 and y dash naught equals 0. This is the initial value problem. And so I am going to apply Laplace transformation to the equation. What is the equation? Y double dash plus y, and this side Laplace transformation of t. Then I can apply Laplace transformation for separately. Y double dash t, sorry, here we have to put t, no, and here also t, and y double dash t plus l y dash t plus lt. Lt we know that 1 over square, no, and y double dash t according to this formula. Where that formula? We can apply this formula, I mean that one, right? That formula for here, and I can write y double dash t is equals s square y of s minus s y naught. We discussed this formula earlier, and y dash 0, and plus l y dash t means ys equals 1 over s square. Then I can apply the initial conditions. Y naught, this part is equals to 0, y dash 0, that is also equals to 0. Then s square y of s plus y of s equals 1 over s square. Then y of s is common, then s square plus 1 equals 1 over s square. Then y of s equals 1 over s square times s square plus 1, right? So then again partial fractions, use the partial fractions. Then you can find s square s plus 1 equals, after finding the partial fractions you can take 1 over s square plus 1 over s square plus 1. This part do it in yourself, finding the partial fraction, that is up to you. After finding the partial fraction you can take this answer, right? So you can't write it that is directly. First you have to find the partial fraction of this this one, and then you can write this as it is. I didn't do that part, keep it in your mind. I wrote this one by finding the partial fraction. I didn't wrote how to find the partial fraction of this one. Okay, so you have to find the partial fraction in yourself, then answer is come as like this. Then we can write y of s equals y of s equals 1 over s square plus 1 over s square plus 1. Then we can find yt by taking the inverse Laplace transformation of 1 over s square plus s square plus 1. Then you can take Laplace transformation, inverse Laplace transform separately, L inverse 1 over s square plus 1, right? Then finally y of t, you can write L inverse 1 over s square means t, no, t, and 1 over s square plus 1, that is sin t, no, because sin a t, you know that sin a t equals a over a square plus a square. Now 1 1 here, no, then this is sin t, t plus sin t. This is the answer. That is all about the differential equations 2, that Laplace transformation, and also about the whole course, that is the last lesson and last part. Based on this lesson also, you have a tutorial. You have to submit that tutorial within the given time, and also now your course for the differential equations 2 is over. So if you have any problem related to this all lessons, you can ask from me. Then next we can meet with the final examination. Thank you very much.